What is going on, everybody? I am Farley back here again today to give you part 5 of our in-depth scripting tutorial. Sorry for the wait between this episode and the last one. I've had a lot of stuff going on in my life last 2 weeks I can't even tell you about. Um, but we're here again today. It's going to be a good lesson, and we're going to get through it, and you're all going to be amazing scripters. So, let's just go ahead and jump right into it. Today, we're going to be talking about dictionaries. If you remember last time we talked about tables, a dictionary is a type of table, okay? It's one of the most useful types. There aren't that many types, I don't know, I imagine that there are, but it's super useful. I have two different examples here today. I know the last episode was probably a little confusing, so I'm trying to keep on hitting on tables, and as we go through more tutorials, I'll continue to use them because tables are just incredibly important. But just keep on trying to figure it out. Look it up on the wiki, read some stuff about it. It'll make more sense the more you do with it. Just like I said, with everything, don't get overwhelmed. It'll come to you in time. All right, so let's get started. The first thing we're going to do, we're going to make a script that will read from a dictionary and use that dictionary to change the way a part looks, okay? So let's first talk about what a dictionary is. So local part props, this is for part properties, is what that would stand for. All right, so in your table, you could just have like a bunch of numbers and strings and whatever, and that would be a table, right? That'd be fine. And these would each be indexed by a number. So this would be part props 1, this would be part props 2, etc. Okay, just the order they appear. In a dictionary, we can do something different. We can go, so number equals 1. We could go string equals high. Okay, so what this would do, instead of calling part props 1, we would now call part props number, okay? And this would be equal to 1. It would not cast an error, it's just because we're not doing anything with it. But, so this would be equal to 1, okay? So basically a dictionary is just like a table, except for instead of calling like part props 1, we'd call part props and then whatever its index was, right? Alright, so it's pretty simple. That's that. So we are actually going to use this table for our script. And what we're going to do here, let's make a new part and look at its properties. So if we just go over to Advanced Objects, double click on Part, and then here are all the properties of a part. Some of them are read-only, which means that you can't change them. Alright, so class name is read-only, you can't change that. Parent is not read-only, but it's still not shaded, but that's for a different reason. But you can change parent, but you can't change its class name, you can't change its gravity, its resizable faces, all of this, okay? So those are read-only, which means you can't change them. But the ones that are not like that, rotation, position, rotation velocity, transparency, reflectance, material, all of those we can change. And that's what we're going to do. So we're going to go into here, and we're going to make a dictionary which says all the properties we want to change and what we want to change them to. So if we wanted to change material, we would do this, and so let's change it to concrete. If we wanted to change brick color, which of course we do, everybody wants to change their color, right? We could go brick color equals brick color dot new bright green. Let's make it green, sure. Bright green is a color, by the way. So brick color dot new. A brick color is a value. Okay, it's not just like the Roblox has to have a way to store what each of these colors looks like, okay, and how it gets them. It does that in a brick color value. Okay, so you know your vector3 value holds 3 different numbers, right, for the x, y, and z coordinate of a position in the world. Well, the brick color is the same thing. Where this vector3 is used to give the position of something, a brick color is used to give, as you may have guessed, the color of something. So color is done in RGB, which means red, green, blue, which I'm sure you've heard about in art class before. It takes 3 values, a red value, a green value, and a blue value, puts them together to get a color. So a color 3 value will be a red value, so 54, a green value 89, and a blue value 34 if we wanted, okay? And then it would take those three and make a color out of it. So if we go ahead into here, I'll show you, we can make a color 3 value. And here you can see all the different numbers. So if we go 54, 89, I just made these up by the way. 34, you can see we now have this greenish color. If we went 25500, it'll be red. Okay, because RGB, red is the first number. 255 is the max. So if we go 0, 0, 255, it'll be blue. Okay, so if we combine these together, we can make a whole load of different colors. All the different colors on the color wheel, with like a purple there, or magenta. So that's what a brick color value is. It's a little bit different than a color 3 value because it's obviously a different value. But in essence, it's the same thing. So just know that whenever you're getting a brick color, you have to call brick color.new. Okay, that's really all you have to understand about that. But it's always good to have more knowledge. All right, and finally, we'll go transparency equals 0.5. Okay, actually, let's go 2.5. There we go. So this will, whenever we're going to use this table to set apart material to concrete, its brick color to bright green, and its transparency to 0.25. So let's make the actual thing that does that. So we're not going to make a function here, since we don't really need one for this particular script, but we'd almost always need one. But this is just for demonstration purposes and to help you understand what a dictionary is and how it works, so we don't need a function for this. What we're going to do instead, we're going to go for I equals 122 local. Actually, let's make a table up here first. So local parts equals an empty table, and we're going to put all these in here. So table.insert instance.new part, and then we'll put it again in workspace. So this is a new function by the way. Whenever you call table.insert, I actually forgot to do this. It gives two parameters. You have to pass it a table that you want to put the new thing into, and then something that you're going to insert into the table. In this case, we're going to put an object, a new part, inside of the parts table, okay? We're going to do it 20 times because we're in this for loop that counts up 20 times. All right. And then, so that's that. We don't need to do anything else with that. Yeah, they're gonna fly all over the place, but that'll be fine. So these are gonna make like a little explosion whenever they are spawned. I'll just go ahead and show you, because they're gonna be spawned right on top of each other. So if we go ahead and click run, you'll see. There you go. They went all over the place, and that's fine. We don't really care. That's totally okay. We just needed to change their properties. So what we're gonna do now, we're gonna go for IV and pairs parts do. This is a new type of for loop which you have not seen. So let's talk about it. For IV and pairs, it's very much similar to the for I equals 1 blah 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 loop, alright? I is still the index, except for V is the actual object at this index, okay? Once again, I and V are both, they're just traditional, like this could be index, this could be part, or whatever you want to call it. They're just names, okay? That's just convention to call them I and V. Don't worry about it. So if we were to call for IV and pairs on and then pass it part props, what would happen is it would loop through the entire part props dictionary or table, and it would start with the first index. So material would be the first I, and concrete would be the first V. Then it would loop through again. Brick color would be the second I, and this would be the second V. Then it would loop through again. Transparency would be the first I, and 0.25 would be the transparency would be the third I, I'm sorry, and 0.25 would be the third V. So basically all of for IV and pairs loops does, it goes through whatever table you pass it, and I will be the index, okay, and V will be the object at index, or the string or whatever at that index. So once again, these are the most important thing you'll probably learn. I mean, you use them just incessantly all the time, everywhere you go. They are so important. But don't freak out if you don't get it. You just got to keep messing with it. Like I said, it's pretty chill. Learn how to script. You just got to keep on working at it, and it'll make sense eventually. But here we go. So what we're going to do is actually way simpler than you might think to do this. I was actually pretty surprised at how simple it was whenever I was looking at this earlier. So we're going to loop through the parts table. So we're going to get all 20 of these parts in there. And then for every one of those parts, we're going to do this. So for IV, actually we can't do it. You can't, if you have a loop inside of this thing, you can't use these two again because it'll think you're talking about these two whenever you're actually talking about these two or the other way around. So we're going to call I2 V2 in pairs, and you should always be descriptive with your variable names. So what I'm actually going to do, I'm going to keep I like that, but we're going to call this part, okay? Because every time it loops through, it's going to get one of these 20 parts. So V is always going to be equal to an instance.new part, all right? And then the index will just be 1 through 20. So we're going to call for I part in pairs parts do. Then we're going to call for I2, oops, I messed that up. For I2 prop in pairs part props do. And since everything we're going to call is going to be properties, this is actually, there we go, prop and val, because I will be equal to a property name every time, so material, brick color, transparency, and then it's the value of the property will be v. Okay, makes sense? Hopefully so. So what we're going to do now, we're going to call part, since every time we're loop through all 20 of these parts, and so it'll always be a part here, and we're going to call part prop equals val. Okay, so what it's doing, parts is full of 20, this table parts is full of 20 different parts. We're looping through so that for all, like, it'll loop through 20 times, and part will be equal to each of those different parts. Every time it loops through that, we're also looping through part properties. So whenever we have our part, we loop through part properties, and we set whichever part we're on in this current loop through, it's going to change its material. So that's calling part material, setting it equal to concrete. So val is concrete here, prop is material here. Then we'll loop through again inside of this loop. We'll loop through again, and we'll set brick color. So prop is brick color. Set val equal to brick color new bright green. Val is equal to that. Okay, so you see it lines up, right? It makes sense. Don't get freaked out if this makes sense. I can't stress it enough. Just stick with it. You'll get it. Now we can press play and we'll see all of our parts are 0.25 transparency. They are made of concrete and they are very green. So that is that. That's the dictionary rundown. Now we're going to do something else. Don't worry about all that if it didn't make sense. Hopefully it did, though. We'll see. I did my best to break that down for you, but just know that a dictionary is just like a table, except or an array, except for the indexes are not like numbers. They are strings, okay, in brackets like that. So now we're gonna do one more thing in this episode. We're gonna make a new table. Local creators equals this. All right, so this is gonna be a script that you can actually use in your game right now. Be something a little bit cool, nothing too fancy, but it'll be a little cool, and it'll also help you once more with tables. Excuse me. So this one is not actually a dictionary because we don't need a dictionary here. Okay, so never use dictionary if you don't have to. Just use what you need to use for that particular thing. So what we're gonna do here, this script, whenever you join your game, and if you're in this table of creators, since you own the game, you'd be the creator of your game. It's gonna announce to the server that you, the creator, have joined the game. All right, that's all we're gonna do. So we're putting player one in here because that is what we need to test it, and then this would be your name. I used to use my player name so that you would see that it's you. So we're gonna use once again our good old player joined connection. And the player is that player joined connect function player. And if, actually, for IV in pairs, this is once again showing you that loop, which is infinitely important. I cannot even explain to you. So we're going to run through the list of creators with this loop. And if v equals player.name, then. So what we did here, I'll just stop and recount for you. We made it a for in pairs loop is what it is. It's called for in pairs loop. I don't know why I've been saying IV. These are optional. Once again, you can name this whatever you want. But for in pairs, we sent it the creator's table. So it's going to loop through this whole table. So player is going to be the first index. Grid Oculus, I mean, player is going to be the first V. Grid Oculus is going to be the second V. I for player 1 would be 1. I for Grid Oculus would be 2. Okay? Oh my goodness, where am I sneezing from? um, so yeah, so I is 1 for player 1 because it's the first thing in the table. I is 2 for Great Oculus since it's the second thing in the table. V is player 1 here at I equals 1, and V is Great Oculus at I equals 2, okay? So I'm trying to make this as simple as possible. Hopefully it makes sense. If not, don't worry about it. You'll get it. Just keep on working at it. So if V equals player.name. So a new player joined. We're going to run through the table. If inside this table we find that the new player's name equals to V, then we're going to do something else. Okay, so that means that it is a creator or the creator of the game, whatever. So what we're going to do, we're going to make a new local m equals instance dot new object, a message, which is really old and people don't really use anymore, but it'll get the job done. You'll see it. We'll put it into game.workspace. Nowadays, people usually use GUIs and stuff, but that's a lot more complicated, so we're not going to worry about that right now. But in the future, we will maybe revisit this script. We'll see. Local m equals instance.new message game.workspace. So m.text equals the game's creator. And then we're going to put player.name has entered the game. Let's put a comma here actually. So yay, the game creator entered the game. So now what we're going to do, we're going to play solo. And since our name is equal to player, oh, what did we mess up? Player joined. What am I doing? Player joined? Oh my goodness, it's not even close to a function. All right, here we go. You'll see the game's creator, player 1, has entered the game. Yay! And that's because our name is player 1. And inside of the script, we have player 1 inside the table. But we actually need to wait for 3 seconds. And then destroy. Destroy is a new thing you haven't seen yet. As you may guess, it destroys whatever you tell it to destroy. It's not very complicated. But yeah, that's that. And well, guys, that's going to be it for this episode. This is a script that will work 100% right out the box. You can put this in your game, and it will work just the way it's intended to. Unlike the other ones, which have been purely for demonstration, you can use this one if you want to feel special whenever you join the game, which you should because you made a game, and that's awesome. But yeah, that's it. I really hope that this was educational to you and helpful in understanding tables and dictionaries, and most importantly, for and pairs loops, because those I can't even express to you how often I use those in my regular scripting. But yeah, that's that, guys. Please subscribe to the channel if you haven't already. Leave a like on the video, a comment. Please comment below what you would like to see in future tutorials or other video ideas you might have for me. Just what you want to see, guys, I'm down to make. That's that. Please share the channel. Help out your friends who might want to be scripting as well. And you know what? I'll see you guys later. Thank you very much for watching. I am Farley.